Okay, so today we're going to look at what you have learned with translations and completing the square actually join together, how they actually mesh and help us learn how to graph. Hopefully at this point you understand how to do translations and you've watched that video and you understand that there's simply just a shift to the right or left or up and down. And so when looking at some questions here, and I'm going to just quickly scroll through these. When looking at these graphs, in particular this first one, x squared plus y squared equals 9, my hope is that you remember that that is in fact a circle with a radius of 3. Good. And so in looking at this next equation, many times we think of these as being something completely separate. But the first thing I want you to notice is it actually is coming from the same exact equation. In fact, if you were to take this x minus 1 and replace that with just simply an x, you could see the x squared. And in place of this y plus 2, replace that with a y, you see it's x squared plus y squared equals 9. So now what in fact do those mean? Well, hopefully you remember from the translation part that we did a couple of days ago that this is just the same exact circle except it's shifted. The one that you see drawn here has a center at 0, 0. And we can see that in the equation, the center is just 0, 0. There's nothing being done to the x or the y. However, this is telling me here with x minus 1 that it's actually being shifted. In fact, it's being shifted to the right 1. And the y plus 2 tells me that I'm going to go down 2. Remember that it goes opposite of that sign. So the same exact circle that you see up here with the centered at 0, 0 and the radius of 3 is the same thing here, except the center is no longer at 0, 0, but at 1, negative 2. And that would be where the center of the circle would be. The radius is still 3. And so in drawing these, I'm not going to get especially specific about them, but one of the things I am going to pay attention to is if the radius is 3, then it needs to make sense and it needs to be scaled correctly. If you're telling me that this is 2, then 3 would be beyond that a little bit. And if we know that this distance here is 1, then that must mean that the distance here is 1. So away from that point, I would need to go at least a couple more. And so that part of the circle would be here. The others, we would just go down by 3 and over by 3 all the way around to get the rest of that circle. And so that would give me my circle. The main point that I'm looking for, though, is the center and that your radius is scaled correctly. With that in mind, looking at this next equation, what would be the root graph of that? Remember, we talked about those 5 basic graphs. So which one of those basic graphs would this be modeling after? It is the y equals x squared. Can you see that? I hope so. And in fact that it's a y equals x squared and it's just shifted. So instead of the turning point being at 0, 0, which is what that would be, I'm going to just ungroup this here for a moment. What happens instead is it's going to go, to the left 2, right? And it's going to go up 3. And so that's all we would need is that this is the turning point of negative 2, 3. And if you remember from Mr. McCarthy's geometry class, for those of you out there that had Mr. McCarthy, you remember that the parabola has that nice pattern, nice symmetric pattern, that as you go over 1, or as you move away from your turning point, over 1, you go up 1. And as you go over 1 more, you go up 3. And that brings you to your next point. And then over 1, up 5, and over 1 and up 7. I'm sure many of you can remember that if you had Mr. McCarthy. Now looking at that, wouldn't it be nice, though, if every equation was written like that? But let's be real, they're not. They're written in the forms that you see here. Now I'm going to skip that first one, and I'll come back to it in a second. What I want you to be able to do is look at a standard quadratic equation and see it as a translation, which will require us to know how to complete the square. So this is where that kind of collides with translations. So what I want to do is I want to write this as something squared. Now hopefully we're pretty good at this point, and you understand that what you're going to do is take that middle term and divide it in half, making that x plus 2. And so x plus 2 squared, again in our minds we're thinking, oh wait, that's x squared plus 4x plus 4. So there's that extra 4, so we would have to subtract 4. And to write that in the form of a translation, let me just write it like this first so you can see it with the y next to it. What we want to do is bring that 4 to the other side, so what it looks like is y plus 4 equals x plus 2 squared. So we recognize that this is in fact a parabola that has a turning point at -2, -4. And so I drop that point, I draw my parabola, and that's all that I'm looking for. All right, changing gears again, let's look at another one. So let's try that. And if you want, pause the video at this point and see if you can do this one on your own. Again, start by completing the square, figuring out what that equation would look like as a translation, and then doing that graph. And if you go ahead and pause this now, then go ahead and then come right back and I'll be explaining it to you. So if you've returned back with me here, we're going to write that as completing the square. You should have had x plus 2 squared again. And again, it's x squared plus 4x plus 4, but we only want plus 1, so I'm going to subtract 3. To write that as a translation, then, that would be y plus 3 equals x plus 2 squared. So what happens is this graph that we had here would then, instead of being here, it would in fact go to the left 2, which we already have, but instead it would move up 1. I'm going to do it in pieces here. So my turning point instead would have been at -2, -3. Good. All right, this next one I'm just going to leave for you to do on your own. In fact, as proof of your notes, I'd like you to have that one done for me, x squared plus 4x minus 8. But I'm going to step away and now do this more difficult looking question here that many of you probably would cringe at the thought of doing. But the truth is it's not that bad. The first thing I want you to recognize is, what shape is it? It's a circle. And how do you know it's a circle? Good, the x is squared and the y is squared. Now the technique to doing this, or at least the first step of this, is to start by grouping together your x's and your y's. And then what you're going to do is actually do 2 different completing of the square. So we have x minus 2, so that'd be x minus 1 squared, so that'd be x squared minus 2x, that'd be a plus 1, right? And then we'd have y plus 2 squared, so it's y squared plus 4y plus 4. So that means we have the extra 4. So what we have instead here, we would have to subtract that 1 and subtract that 4. So we have, x minus 1 squared, and y plus 2 squared minus 19 equals 0, right? Or to make it look more in the shape of a circle or an equation of a circle, you remember the radius is always written on the right there. So this means that we have a circle centered at 1, -2, with a radius of the square root of 19. And we know that that's more than 2, so it's going to fall somewhere over in these directions. And then that's enough preciseness for me. I'm going to just write in here square root 19. And that is what we're looking at. And that is how completing the square and translations kind of go hand in hand. And hopefully that helps you in terms of your graphing as you move forward.